to remember whatever was injected in your system through your B cells and T cells. And that process is called generation of immunological memory. That is the aim of any vaccination. And this slide actually try to explain that. Okay. Now, on y-axis, we are looking at, for example, the antibody titers. Okay, your B cells are activated, and these antibodies will start forming because of your B cell activation process, right? And on x-axis, you are looking at time following vaccine. Okay, so you got this vaccine here. And this black curve, actually it shows the titer of antibody formed. Your B cells are activated, they start spitting these antibodies, and these antibodies will increase in number. They increase, but they reach a peak at some time point. Okay. But after a certain time, when the antigen has disappeared from your system, whatever antibodies are protein molecules, they have a half-life. They will be degraded after some time, or they will be cleared off from your system. And then there will be reduction in the antibody titer. Right? And if you wait for enough time, so chances are that you will not have antibody at all in your system. This is usually true for any vaccine. But what remains? What remains as a result of this vaccination in your system is your ability to remember. Okay, we are actually talking about immunological memory. That means you have those antigen producing B cells or T cells which can make these effector cytokines. Okay, and they are specific to this vaccine. Okay, their number increase, and it reach a stability, and it remains in your system forever, almost, for good vaccines. So this is the fact that your immunological memory remains forever. Okay. So once you got a vaccine, and if it engaged your immune system once, you are going to generate memory. And these memories are going to stay in your system for a long time. Unlike antibodies. Antibodies basically are produced, and then their titers. Titer means the concentration actually goes down. And then you can start saying that, yeah, now the vaccine is not working. No, vaccine is working, because vaccine, the purpose of generating this or injecting this vaccine is to enhance this immunological memory. Yeah, obviously what can happen is, for example, if you get a boost here, again, whatever memory cells you have generated for B cells, they will be activated much more rapidly, and then your antibody level again will go high. Okay, but you cannot keep on doing that for following active immunization. The purpose is you generate a good immunological memory, and then if how these immunological memory cells actually are recruited in the response. See, initially maybe it took this much time, maybe 6 days time or 10 days time to generate to this level of antibody response. Okay, but at this time point, for example, if you give a second dose, so within 2 days, so you will generate this much level and even more than that. And why this is happening is because your memory cells have already seen antigen once, and now if you give this antigen, they get activated very quickly. They start making good quality antibodies and so on and so forth. But this is not the case for the first time. Question on this slide?
So, sir, by serum antibody and immunologic memory,
yeah,
do you mean that the memory T and B cells will keep on increasing, and CD8, CD4 cells will degrade with time.
Well, if you talk about real immunologic memory, this is going to be constant. Okay, so these, for example, if you activated your B cells or T cells, you made, let's say, 100 cells which are actually now specific to this vaccine, right? Over a period of time, some of those cells, rather a large majority of those cells, almost 90% of those cells are going to die. You are left with only 10% which remain in your system as immunologic memory. But that 10% will remain 10% forever.
So what consists of serum antibody over here?
Serum antibody is basically, if, for example, you collected blood and you collected serum and you measured that in that serum, how many antibodies are specific to that vaccine. Okay, initially you had a lot more, but after let's say a month or 6 months, you detect the number of those antibodies are going to reduce. And the simple reason is because these memory cells, they will not keep on making these antibodies if without sensing antigen, right?
Yeah, sir. Okay.
So, and remember, so antibody are secreted product of your B cells. So they are actually circulating in blood. And it's not like if you have 1 million antibodies at day 7 or day 15, you will still have the 1 million antibodies against this vaccine after 6 months. No, it will be maybe 100 times. It's only 100 or it's only 1000. This is usually what happens for any protein produced by your cells, right?
So antibodies will be generated only in presence of antigen, irrespective of the presence of immunologic memory.
Well, yeah. So see, for example, initially you activated your cells. They are going to make antibodies, and some of these cells will become memory cells. Now they are not making antibody unless you activate them by injecting antigen. If you inject antigen, so then antibody response will be high. Okay.
Yes, sir.
But the purpose of any vaccine is to promote or to set a threshold of your immunological memory, that you already have achieved this sufficient immunological memory, and that's it. That will be protective if you get infected with the same virus again. And that is why, so some people say that this Omicron or whatever, it's mild. I don't think it's mild. It's just that because a lot of people have developed antibodies, they have developed T cells, and now this virus is controlled much more efficiently. Okay, and that is why this has become milder. Okay, so question in the chat box is, why do certain vaccines have boosters? Is it because immunological memory that was created initially was not enough? Yes, that precisely is the reason. That also depend on the microbe you are dealing with, the virus that you are dealing with. Okay, yes, viruses do change. Okay, also, doesn't the number of memory cells decrease with age due to senescence and other processes? Well, I said almost for the rest of your life. Okay, so it was recorded for smallpox. Okay, almost similar level of immunological memory remained in your system even after 75 years. And 75 years is more or less your lifespan. Okay, that actually is the definition of memory. Yes, for some other viruses, this is the case with smallpox, right? But with other viruses, yeah, it may be 20 years, it might be 15 years, it might be 20, whatever, 25 years, 30 years. So that varies from infectious agent to infectious agent. What kind of vaccine did you take, whether it was natural infection, whether adjuvant was added. So all these things are going to decide what quality of memory response you are going to generate. All right, so next. So we have some time, so let's very quickly talk about, or maybe in tomorrow's class we'll do it. If you have any questions, so we'll take your question. Otherwise, so we'll start this herd immunity concept. Let's cover this slide, and we'll continue with this in the next one. Okay, so herd immunity is the immunity at population level. Okay, it reduces the number of susceptible hosts and increases the number of resistant hosts. And these two things, once you have reduced the susceptibility of host because you have made them immune, and second is you have increased the number of resistant host, and this whole thing is going to decide, these two things are going to actually reduce the frequency of acquiring infection at population level. This is called herd immunity. Now, again, the major question is, what is enough? Even before that, in other words, if enough of a population is vaccinated or have gotten exposure to natural infection, okay, and they are now immune, so even unvaccinated individuals are protected because they are unlikely to encounter an infected individual. So that's in essence herd immunity means. Okay, some individuals are not vaccinated for various reasons, and they might respond poorly. Okay, so that is why one has to rely on herd immunity as well. It's not like out of 100 individual, if you give the same vaccine, same everything, so each of those 100 individual is going to mount equally potent response. No, that's not true. At population level, it varies. Okay, now we are going to stop, I guess. Okay, so I will continue from here onwards.